What?
So tight.
Wow.
Remember when she went to try all these websites that have games and she got into one and she clicked on a game. It's like, wow.
Okay. Today is 12/10. And yes, this is stuff from Unit 3, even though we haven't finished Unit 2. But as I explained, I just kind of want to get away from this absolute value thing for a little while. I feel like we're just drenched in it. You guys did really well on your retakes, by the way. So good job. The math was pretty simple to calculate. I didn't quite give you full credit since so many of you decide not to do your practice quizzes for some creepy reason. But you did get a lot of points back. Some of you a ton. So good job on that. So Unit 3 starts, it's all systems. Unit 3 is entirely systems. And there's going to be some word problems and some big triple systems. It's a fun unit. But for the next few days, we're just doing Algebra 1 review. So we're going to solve, we call these 2x2 systems. So that means that there are two equations with two variables. So eventually we'll do 3x3s. And once you know the art of solving a 3x3, then you could extend that if you wanted to solve a 4x4. You can go on and on using the same methods. But so today we're going to solve 2x2 systems, but we're only today going to talk about graphing. There are three methods, and the one we're going to talk about is called graphing. And like I said, I think I decided not to blow through all three methods today just because I think there's going to be some carryover sort of residual issues from Algebra 1 with getting y by itself and graphing lines. So I thought it was fair to just take one whole day and dedicate it to that. So I've got 5 examples, 7 examples. I don't know that we'll do them all, but our first one is this. And this will be hard for you to take notes on just because I get to have a piece of digital graph paper. That little fellow I get to have, and you don't have that. So you'll have to just kind of get creative. Sketching should be sufficient. I think most of our issues aren't going to be with the graphing. I think we're going to probably talk mostly about how we get y by itself, just a guess. So the other equation in the system is y equals -1/2 of x plus 3. So it's been quite a hot minute since most of us have done this, graphing lines. You had to do a little bit of it in geometry, but I know we did a ton of it in Algebra 1. So anyone remember how to graph the first line? Good job. And so we're going to start very specifically at down 4. Remember that there are two -4s on the axis on the plane. So we want to be real particular and say we're going to start up 3, down 4, down 1. Because sometimes people start on the x-axis, which is pretty weird. So we're going to start by going down 4. And then from there, where do we go?
Up to the
Perfect. We know that the slope of this line is positive, so we know the line has to tilt uphill, right? So at the end of the day, as long as our rise and run are in a ratio of 2 to 3, as long as we form the correct uphill slope, that's the key. And you'll want to do that as many times as the graph paper will allow. And so I know that's, again, hard for you because you're probably using notebook paper, but that's the gist. And then you grab a ruler and you graph the line. That should just come like flooding back to you, like we never left, right? It's like riding a bike. Graphing lines is pretty easy. Where are we going to start the second line at? At up 3, very well spoken. And what's the slope? Well, careful. No, it's rise first, run second. So
down one right one.
I would accept down 1 and right 2. Yes. As long as, again, at the end of the day, and I struggle with this as an algebra teacher, that, what really dominates our thoughts is that the slope is negative, and negative lines just have to go downhill. I mean, it's amazing how often we overlook that fact. So you go down and right if you want. You also could have said to go up and left. You see that either of those motions creates a downhill line with a ratio of 1 to 2. 1 uppy downy for every 2 to the side. So slope's pretty easy once you get your head around just understanding positive, negative. And that shouldn't be the challenge that it is, but it often is. And then again, you'll grab a ruler and you'll connect the dots. And our job when we solve a system by graphing is to look for the point at which the lines cross. And the point is pretty obviously right there, that large purple dot that I just made. And so what is the name of that point? It's something 0, right? We can say that for sure because it looks like it's on the x-axis. So how far right do we have to go? I think it's 6, but it's hard for you to see, but 1, 2, 3, 4, 5, and then you got to go that one more. So what this means is that if you were to plug 6 in for x and 0 in for y, it would make both of these equations true. They would both be what we call solved. Does that ring some bells? Okay, so what's going to change now throughout this lesson? And again, I don't know that we need to do them all, but each one, I tried to make them all have a special flavor. What's going to change is that I'm going to make you do math now, right? That wasn't mathy. That's just, do I know how to graph a line? So as we change it up, we're going to see systems like this. And what right away do you notice is different? Good. So this top equation is the one that gets a little sad face because it's got work to go. Like I got to get it cleaned up before I can make the graph. And so this is mostly what we're going to talk about today is how do we get y by itself. But we're pretty good at this math stuff. So what would we do first to get y by itself in the top equation? I would move the 2x to the other side. So I would leave the negative 3y, and then I would tuck the 2x right after the equal sign. And of course, I change it to negative 2x when I move it across. And then the -9 just kind of scoots aside. I'm always going to try to keep the same format of the y equals x number. Like you're not going to see me zero, of course. So if you want to, if you're one of those people that puts -9 and then -2x, if it works for you, that's fine. That's just not something I do. And then what's the last step? We divide. And remember that when we divide in situations like this, we divide very explicitly by everything, or everything by is what I should say. So we want to make sure that we're attacking each piece individually. So we wind up with y equals what? Perfect algebra. And so now we would graph the two lines and we would see where they cross. So we don't necessarily have to go through and graph every problem, but just because really the math is more what I'm worried about today. What my only concern here would be with this purple line. Where do we start? Down 4. And the slope, maybe we're a little rusty. How do you attack a slope of 3? You go up 3, right 1, correct? As long as your line goes uphill, that's the key. So, I mean, if you were wanted to go rogue and go down 3, that's fine. Just make sure you turn back to the left to keep that positive uphill slope, right? And then so these lines would cross at a certain point. Can I forego the graphing on this to save a couple minutes? Okay, then let's look at the next example. And again, I think I can skip the graphing on quite a few of these. There's 2 more where I think I'm going to need to graph with you just to remind you of something. So for this next one, we have 8x plus 4 minus y equals 0, and -3 equals -x plus y. You figured this out in algebra, and it's easy. I think a lot of times when you come back and see something a year later, or for you guys, like some of you 2 years later, you start to see things with more clarity. The idea here is just to match the mold. The idea is just to be a little robot and say, I want my y here, I want my x here, I want my number here. Like that should just be what we strive for. Put everyone where they need to be. Math is pretty easy when you see it that way. So on the top equation, I feel like there's a smart strategy, there's a quick one, or there's the robotic. What would you guys do in a case like this? Say it again. Good. And that's something that we wouldn't do like first day of Algebra 1, but in Algebra 2, I think we can see that with clarity that we can match the mold if we just toss the y across the equals, right? And that gives us a final ready equation of y equals 8x plus 4. I switch the sides, but yeah, who cares, right? But by moving the y, I avoid having to keep that negative on the y. So it's a smart play. If that y had been plus y, I would have left him there and moved the 8x and the 4. How about the second equation? Again, I just think about what am I trying to accomplish? I mean, at the end of the day, I want y by itself. Right and left don't matter. Like that's all relative. Who cares? But if I get the x across, then I have y equals a positive x and a minus 3. And again, those lines are ready to graph. So does anyone feel like we need to go over the graphing? If you have a hard time in a little bit when I hand the packet out or the worksheets, that if you want some clarification, like on graphing lines, I can come and work with you, just get you caught up on how to graph lines. This one I am going to graph with you because it poses just something that we likely have forgotten about because it's what we humans do. So top equation, what's our strategy? There's a perfect play. What is it? I wouldn't. I'm immediately attracted. My eyes are attracted when I see a minus on a Y. I look at this minus on this Y and I say, you, sir, are no good, right? So how can we make him good? We move him to the other side. Correct. And if we move him over, he becomes positive Y, which is exactly what we want. But then when he lands over there, he's like, wait, I'm not supposed to have any neighbors, right? So who does he move in next to? Mm-mm. The 3. And I don't want the 3 there. So what I say is, well, if you're going to come over here, then 3, you're going to have to show yourself to the other side, right? So we get x minus 3, correct? And again, that's ready to graph. What's the slope of that line? 1, which we would think of as 1 over 1. So we remember the ratio of up 1, right 1. To save time, rather than, you know, up 1, right 1 over, you could do like up 7, right 7. As long as that ratio remains consistently 1, you can save time that way. And then, of course, you can backtrack down and left as long as your slope is uphill with a ratio of 1 to 1. Okay. That's not the one I wanted to talk about, though. What's unique about the second equation?
It's just
Good for you. Good memory. Thank you for remembering that. I'm impressed that remember when an equation doesn't have any x's in it, it is horizontal, right? This isn't a slope intercept kind of situation. This is just y equals a number. And so we do have to move the 2 to the other side. And when we do that, we get the equation y equals -2. So I did want to graph this one with you. I think there'll be this one and probably one more that I graph along with you. Shrink that down. Move it over here. There. So help me with the red line. Where would I start the red line at? Thank you. Good job correcting yourself. I appreciate it. And then again, to save time, you can do, here's what you don't want to do. You might remember me telling you this. Why is that a bad idea to graph a line with only those 2 points? Let me show you what happens. When you put your ruler down, you might think you're doing a really good job. Like you might say, and this probably isn't going to cooperate with me very well, but people would argue, there are some people that would say that my line goes through the red points. Would you agree? It kind of does, but watch what happens as we start to continue to traverse points. If I go up 1 and right 1, I get here, 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 here. Do you see what's happening? So the moral of the story is that you should always have points that are far apart because I keep going up 1 right 1, but clearly I'm not on the red line, am I? So that's why I always say it's imperative to not just graph 2 points that are close to each other. Graph, even if you don't graph 10 points, graph points that are far apart. So when you connect them, you're sure that all the ones in the middle are also on the line because you can get off course by quite a bit if you do a ghetto line. And that will affect us with an assignment like this because we might not get to see the crossing point if our line doesn't behave the way we want it to. Okay. So I'm going to go back and undo all that badness. And so again, the idea is you want to go like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. By locking points far apart, you just can't mess up. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then when you connect those dots with a line, they're assuredly going to go where we want them to go. Everybody got this so far? Now, as far as the other line is concerned, again, what kind of line is y equals -2? It's horizontal. So all you have to do is go down to and graph a horizontal line. These are always, I say, they should in theory be the easiest lines, the single variable ones, but they oddly enough get missed a lot, which is pretty weird. So then that's that. And the crossing point is what? What would we call that purple point? Yeah, it's the solution, right? Was what we call that. And his name is 1, -2. So it starting tomorrow, we'll be solving without the graphs. We'll never see the lines, at least not for a little while. We're just practicing this today. Any questions on that one? Okay. This next one, again, I don't feel like we'll need to do the graphing, but I will if you want me to. The purpose of this example was not to graph a line. The purpose of this example is to refamiliarize you with the fractions, right? So here's our system. Bottom one's pretty stress-free, I think. We'll go through it, but let's talk about that top one first. We hate the top one because of the fractions, right? Do you guys remember what we do? We kill them, right? We multiply by 2. That's something I hope you took away from our year together in the last class, is that we don't have to work with fractions. We can eliminate them. And so if we just put on a pair of parentheses, monster brackets, whatever you want to call them, and just multiply, sweep through by multiplying by 2, it's a wasted step technically, but it's good because it gets rid of the stress. So if we multiply everything by 2, what do we get? Nope. 3. The 2's go like this, kapoof, kapoof. That's the whole point of multiplying by 2, is that the multiply 2 and the divide 2 just kill each other and they're gone. No remnants, right? Equals, and then what do we get? -3y. And now it's pretty stress-free because we're in a position now where we don't have to deal with the fractions. So let's finish off red guy. What would we do? Divide by -3. So if we divide every portion of this by -3, then we will be in the position that we strive to be in, and that is y by itself. So we'll have y equals what? What's our slope? I love it. -2x. Just like that. And again, during the work time today, if you need help with graphing that line, that's okay. Just reach out. I'll help you. All right, let's talk about this second line down here, the yellow one. What's our strategy here? You can, just to make it positive. You like that better? It's up to you. Some people would just move the 4. It depends where your comfort zone is. Some people are really, really averse to negatives, and they would take that step and just say, you know what, before I get started, I'm going to go ahead and just switch this guy over here to make him positive. But if he goes over there, who else has to move? Then the X has to like show himself the door, right? And that's fine. So if we do that step, then we get 2y positive, the X becomes negative, and the 4 just watches it happen. So I didn't dislike that at all. Now what do? We divide. Yeah, it's just a mission. It's just Operation Get Y by itself, man. High school math is really, really hard if you can't get Y by itself. And we divide those out, and we're left with our final answer, which is y equals what? What? -1/2 of x plus 2. And you would have gotten the same thing if going back to the beginning. I'm going to write in purple here for a second. If back at the beginning, if you would have moved the 4 across and just left, that would have been fine. And then divide by -2, you're still going to get the same answer, provided that you don't make any mistakes. So slope intercept is non-negotiable. Like it's one of those things, like there is a right answer and lots of wrong answers. So, and then you'd go and you'd graph them. Again, I don't assume you have any questions on that. Okay, cooking through these on the back. I've got two more, and we do need to go through both of these. Each one, again, having a purpose. So our first one, we have -6 plus x equals -2y. And then our second equation is 2 equals -x. Top one, what do we do? Yeah, it's ready. Like, I don't see the benefit of trying to move things around here. Like, let's just get right to it. We're not scared of negatives. So we're just going to divide here. We're going to divide here, and we're going to divide here. You know, an operation get y by itself will be complete. So we get y equals what? -1/2 x plus 3. Perfection. And then, of course, graphing, you go up 3, put a dot, down 1, right 2, down 1, right 2. You just build that little downhill staircase. Easy peasy. But again, this example did not make it onto the note card because of that. It made it onto the note card last night because of this. What kind of equation? What's unique about the second one? The slope is undefined, right? And it's a vertical line. And remember that when only x exists in an equation, the only restriction to be on the line is that your x has to be a certain number. That by definition makes you a vertical line. So how would I get x by itself? Yeah, we got to clean house a little bit. Let's just divide by -1. You know, that's not a step where you have to show work or anything like that. But you wind up with x equals -2. Okay. Again, I do want to graph this one with you, just because it's a unique situation. So let's talk red line first. How would we graph the red line? Thank you. So I'm going to go up 3, put a dot, and then what's the slope? Walk me through it. Down 1, right 2. Yeah. At the end of the day, you are the boss of your line. And when people make negative slopes go uphill, I just always wonder, like, is your heart really in it? Are you in it to win it if you can't understand that? Negative, downhill, make it happen. Just keep your ratio at 1 vertical for every 2 horizontals. Slope is cake. All right. And then as far as the yellow line, what would we do? Go to -2, but go sideways -2, and then graph a vertical line like this. Okay. And then you will see quite clearly that the lines cross at this purple point right here. And what's his name? He's the solution, right? But what's it? And again, that's it. That's called the solution. That's the point. That's the set of x and y's that if you put it into both equations, it magically makes them both work at the same time. That's what we're going to be doing here for the next at least couple of weeks. Okay. And then the last example has more fractions, and I'm not going to bring a graph in for this one because, again, once we get past the y equals part, the graphing will be easy peasy. So this top equation in the system is not the one that I wanted to talk about. It's this bottom one. So let's go ahead and get the top one out of the way. And I could go either way on this. 50-50 split. I would imagine if you asked 100 people, 50 would say move the 2y, 50 would say move the x. So what do you guys want to do? I can't hear you. Sorry. Say what? Sure, that's what I would do. Y is not hurting anybody there. So let's just move the x to the other side. So if I take this x and chuck it over the wall, then I get -2y equals a positive x and a still +2, right? And then what do we do? That's it. And when we divide by -2, then we get our y by itself and we're done. We get y equals, what's our slope? -1/2.
Minus.
Just like that. It's the second guy. This is why this one made the note card. He made the cut. Looking back at this, really the only ones I probably could have dispensed with were like the third example was really the only one that I could cut. What do we do with this one? First thing you should be thinking is killing fractions. We shouldn't be doing anything other than just let's eliminate those. What do we need to multiply by to kill them? 3 will not work. Remember, killing fractions isn't just about killing a fraction. It's about a number that's big enough that it will kill them both, right? So we need a number that will cancel a 6 and will also cancel a 3. And 3 will not cancel a 6. If you put a 3 here, 3 cannot divide by 6. It will leave me with another fraction. So we have to use something here called the least common multiple or the least common denominator. And 6 is the perfect candidate. You could also use 12, 18, 24, 30, 36, but we generally want to pick the one that's the smallest. I want it to be as small as possible, but I need it to be divisible by both of the bottoms. That's how fraction killing works. So in our first distribution right here, what do we get? We just get negative 1x, right? And then in our second distribution, we get equals 6. Very good. And then in our last distribution, what do we get? We get minus 2y. And the reason we get a 2 is because I'm going to switch to green or purple now. When this 6 divides by this 3, there's a leftover, right? Remember the hook? 6 divided by 3 is 2. And then you grab that 2 and you multiply it by the top. And that's where the minus 2y comes from. And then from here, it's just smooth sailing, business as usual. So I think if I were solving this one, since I've got to move somebody, I would do this. If I were making an answer key, my paper would look like this. Because I got to move something, so I might as well do that. Get everything positive. Move the 2y, move the x back across. Everyone's positive, everyone's happy. And then we divide by 2. And if we divide by 2, we're done. We get what? Perfect. And then you graph the lines. Okay? You plot some points, grab a ruler, look for the point where they cross, and that's that. So I'm going to hand this out, leave this going, paused as always. I might as well, I'll throw this on the recording. So yeah, we got the up 2, and then the slope is a ratio of 4 to 3. So you'll notice that we don't have enough room to go up 4 and right 3. It would be like up here off the graph, which isn't really a big deal. But remember that instead of going up and right, you could go down and left, and you'll get that same slope. You still have the ratio of 4 to 3. If you go down 4 and back to the left 3. Because sometimes the graph is going to boss you around and not give you enough room. And so then you'll take your ruler. And I'm just going to kind of try to estimate where this is. I'm going to put it low on purpose and then move it up because I kind of missed a little bit. All right, so there's our first line. And then Hugo, where are we going to start the second line at? Right, so we'll start by going down 1, right? Always start on your y-axis. And then what's the slope?
Up 1. Right.
Good job, buddy. That's perfect. Yeah, and then you graph the line, and then you have to name the point. The solution point is really what we're after here. So what is the name of that point?
-3. -2.
And we're done. Problem 1, done. Good?
Yeah.
Okay. So I will give you a little bit of time in class tomorrow to work on this, but I will probably also, this won't be all we do tomorrow, but I will give you some more time because I'm not the kind of guy to send you out of here with a bunch of homework. It's not how I roll. So just plan on a little more time. If you wanted to get 3 or 4 more problems done just to not get behind, that would be pretty smart. If you get it all done, super bonus, then tomorrow will be a breeze. So whatever.